Introduction to AI. Concepts and Applications. Artificial intelligence, AI, has rapidly evolved from a theoretical concept into a transformative technology that is now embedded in many facets of modern life. AI refers to the ability of machines to perform tasks that typically require human intelligence, such as learning, reasoning, perception, language understanding, and decision-making. At its core, AI is about creating systems that can analyze data, identify patterns, and use those insights to solve complex problems with minimal human intervention. This introduction explores the fundamental concepts of AI as well as its myriad applications across different domains, providing a comprehensive overview of this cutting-edge field and its impact on society. The journey of AI began with early attempts to formalize the notion of intelligence and computational reasoning through the work of pioneering researchers who sought to understand how machines might replicate human thought processes. Early models were largely based on symbolic logic and rule-based systems, where explicit instructions governed the behavior of the machine. As researchers encountered the limitations of these early approaches, the focus gradually shifted toward creating models that could learn from experience, paving the way for the development of machine learning. Machine learning, a subset of AI, involves training statistical models on vast amounts of data so that they can improve their performance over time. These models learn by adjusting their internal parameters to minimize error, ultimately enabling systems to generalize from past experiences to new, unseen scenarios. One of the most influential developments in the evolution of AI has been the creation and refinement of neural networks, computational models inspired by the structure and function of the human brain. Neural networks consist of interconnected layers of processing nodes, or neurons, that transform input signals into outputs through weighted connections. With the advent of deep learning, neural networks with many hidden layers have achieved remarkable success in tasks such as image recognition, speech processing, and natural language understanding. These deep architectures are capable of automatically extracting complex features from raw data, a capability that has fundamentally changed the landscape of AI. The performance improvements driven by deep learning have led to practical applications that were once considered the realm of science fiction, from self-driving cars to real-time language translation. Another crucial aspect of AI is the diversity of learning paradigms that it encompasses. Supervised learning involves training models on datasets where inputs are paired with corresponding outputs or labels, making it effective for predictive tasks such as diagnosing diseases from medical images or forecasting market trends based on historical data. In contrast, unsupervised learning deals with data that is not tagged with labels, enabling models to discover hidden structures or groupings in data, which is particularly useful in customer segmentation, anomaly detection, and pattern recognition. Reinforcement learning, yet another paradigm, focuses on developing agents that learn optimal behaviors by receiving feedback from their environment in the form of rewards or penalties. This approach has been successfully applied to games, robotics, and complex decision-making tasks, where an agent iteratively improves its strategy through trial and error. The applications of AI are as varied as they are transformative. In the realm of healthcare, AI systems are revolutionizing diagnostics, treatment planning, and patient management. Machine learning models analyze vast repositories of medical data, including imaging and genetic information, to detect diseases at an early stage and recommend personalized treatment options. For example, deep learning models have been trained to identify cancerous tumors in radiological scans with accuracy comparable to, and sometimes exceeding, that of expert radiologists. Similarly, natural language processing techniques are being applied to electronic health records to extract meaningful insights, helping to streamline administrative tasks and improve patient outcomes. In finance, AI is being used to optimize trading strategies, detect fraudulent transactions, and manage risk. Algorithms powered by machine learning analyze market data in real time to identify trading opportunities and execute trades with speed and precision. Fraud detection systems leverage AI to sift through vast volumes of transaction data, quickly flagging anomalous behavior that may indicate fraudulent activity. This capacity to process and analyze information at scale has given financial institutions a competitive edge, enabling them to respond proactively to market fluctuations and safeguard the integrity of financial systems. AI is also making significant contributions in the field of autonomous systems. In transportation, the advent of self-driving cars represents one of the most visible and promising applications of AI. By integrating sensors, cameras, and advanced machine learning algorithms, autonomous vehicles are capable of navigating complex roadways, avoiding obstacles, and making real-time decisions that ensure passenger safety. The development of such systems relies heavily on reinforcement learning and computer vision algorithms that collectively allow vehicles to interpret their surroundings and adapt to new traffic conditions. These innovations not only promise to reduce accidents and improve traffic efficiency, but also signal a shift in how transportation systems are conceptualized and managed. In the sphere of communication, AI has transformed user interactions with technology through the development of intelligent virtual assistants and chatbots. Natural language processing enables these applications to understand spoken and written language, providing users with seamless access to information and services. Virtual assistants like Siri, Alexa, and Google Assistant use sophisticated AI algorithms to answer questions, manage schedules, control smart home devices, and perform a variety of tasks, thereby enhancing everyday convenience. The ability of these systems to learn from user interactions and offer personalized recommendations has made them integral to the digital ecosystem, fostering greater connectivity and efficiency. The influence of AI extends to the creative industries as well, where generative models are used to create art, music, and literature. Algorithms such as generative adversarial networks, GANs, enable machines to produce original content by learning the underlying patterns from large datasets. These generative models have given rise to applications that can create photorealistic images, compose musical scores, and even generate human-like text. The integration of AI into creative processes challenges traditional notions of authorship and creativity, as it opens up new possibilities for collaboration between human artists and machines. In this way, AI is not only augmenting creative capabilities but also inspiring a re-evaluation of what constitutes art and innovation. Industrial automation and robotics represent another area where AI is making profound inroads. Intelligent robots, equipped with machine learning and computer vision, are increasingly being used in manufacturing, logistics, and service industries. These robots are capable of performing tasks that are dangerous, repetitive, or require high precision, thus reducing human error and enhancing workplace safety. In manufacturing, AI-driven automation systems can optimize production processes, monitor quality control in real time, and adapt to changes in demand. The collaboration between humans and robots, often referred to as collaborative robotics or cobots, is reshaping work environments, enabling more efficient and flexible operations while fostering new skill sets among the workforce. Environmental monitoring and sustainability efforts are also benefiting from advances in AI. Machine learning algorithms are employed to analyze ecological data, predict environmental changes, and optimize resource management. For instance, AI models are used to forecast weather patterns, track climate change, and detect deforestation using satellite imagery. These applications provide critical support for environmental conservation efforts, enabling informed decision-making and efficient management of natural resources. As the global community grapples with the urgent challenges posed by climate change, the role of AI in driving sustainable practices becomes increasingly significant. In the field of education, AI is being used to personalize learning experiences and optimize educational outcomes. Intelligent tutoring systems provide customized instruction tailored to the individual pace and style of each student, delivering real-time feedback and adapting to the learner's needs. AI-driven analytics identify gaps in knowledge and suggest targeted interventions, thereby enhancing the overall effectiveness of educational programs. Furthermore, virtual reality and augmented reality technologies, powered by AI, create immersive learning environments that enhance engagement and improve comprehension, especially in complex subject areas. These applications are revolutionizing traditional educational models by making learning more dynamic, accessible, and inclusive. The rapid development of AI technologies is supported by ongoing advancements in hardware, such as specialized processors and high-performance computing systems. Graphics processing units, GPUs, and tensor processing units, TPUs, have been instrumental in accelerating the training of deep learning models, making it feasible to process enormous datasets in shorter periods. Cloud computing infrastructure provides scalable resources that enable organizations of all sizes to deploy AI solutions without requiring massive capital investments in physical hardware. This democratization of computational power has led to a surge in innovation, allowing startups, researchers, and established companies to experiment with and deploy cutting-edge AI applications across diverse sectors. Ethical considerations and responsible AI development have emerged as critical topics as these technologies evolve. Concerns about bias, privacy, and accountability have prompted the development of frameworks that strive to ensure that AI systems are deployed in a fair and transparent manner. Researchers are working to create algorithms that minimize discrimination by carefully curating training data and incorporating fairness constraints into model design. Explainable AI seeks to make the decision-making process of complex models more understandable, thereby building trust among users and stakeholders. Addressing these ethical concerns is essential for ensuring that the benefits of AI are realized while mitigating potential risks associated with its use. In summary, artificial intelligence and machine learning have transformed from theoretical constructs into indispensable tools that drive innovation and efficiency across countless domains. By harnessing the power of computational models, neural networks, and advanced learning techniques, AI systems are capable of performing complex tasks, making informed decisions, and creating new forms of art and productivity. The applications of AI stretch from enhancing healthcare and autonomous vehicles to revolutionizing creative industries and environmental sustainability. As research continues and ethical frameworks evolve, AI and ML are poised to unlock even greater potential, paving the way for a future where technology and human ingenuity work in harmony. The implications of these advancements are profound, shaping the way we live, work, and interact with the world, and heralding a new era of innovation that will continue to redefine the boundaries of possibility.